All right, here are solutions to our third written problem, Math 243. This question concerns both the empirical rule and figuring out and using the inverse norm and normal CDF functions on your calculator. And there's some instructions given up here. I'll let you read those on your own. Part 1, question 1, I don't know. Using the empirical rule, estimate the probability that Steph scores more than 36 points in a randomly selected game. Well, what you need to know is that we're told to assume that the number of points that Steph scores is normally distributed. So you can draw, that's kind of a weird looking one, a normal distribution here. And then if they're normally distributed, there's two different parameters you need to know. You need to know the mean and the standard deviation. So in this case, those numbers are 30 and 6 respectively. So in your picture, the 30 goes in the middle, and then you count up and down by sixes and space them out in such a way that by the time you are 3 sixes or 3 standard deviations above the mean, you're out towards the end of your tail here. And then similarly, 24, 18, and 12. By the time I'm 3 standard deviations below the mean, pretty far over on the left. And what I'm supposed to do is estimate the probability that Steph scores more than 36 points. So in my picture, I'm talking about this region right here. So I guess the first thing to know is to understand that this shaded region represents the probability that Steph scores more than that many points, 36, I guess it was in this problem. And then the second thing to do is to be able to figure this area out using the empirical rule. And there's several different ways you can get there. In my opinion, the easiest way, or one of the easiest ways, is to recognize that it's not asking you what's the probability scores between 24 and 36, but if it were, that probability would be 68%. Why? Because the empirical rule tells you that 68% of the observations lie within 1 standard deviation of the mean. So this area right here is 68. Okay, that's great, but that's not the answer. Right, but if you know that this is 68%, you can figure out how much area is shaded in blue. And the logic is, if 68% is shaded, then 32%, or 100% minus 68%, is not shaded. And you're like, right, but there's more is not shaded in red. And you're like, right, but the blue is not everything that's not red. There's also this white portion over here. However, because our distribution is symmetric, we know that the white region is the same as the blue region. So if total those comprise 32%, then individually each one comprises 16%. So what that tells me is that the blue shaded region, which is the answer to the question I'm looking for, has an area of 16%. What was I supposed to do? Round, I think I'm in good shape. So I guess that's the first answer. Second one. Using the empirical rule, estimate the percentage of his games in which Steph scores between 18 and 48 points. All right, kind of the same logic, just different calculations. Again, we're talking about points Steph scoring, so it's approximately normally distributed, or maybe it just said normally distributed. 30 goes in the middle, counting up and down by my standard deviation. And then in this problem, instead of figuring out the probability that he scores more than 36 points, in other words, the area shaded to the right of 36, what I'm supposed to figure out is the probability he scores between 18 and 48. In other words, the area in between 18 and 48. So this large shaded region here. And how do you figure that out? Well, it's kind of hard to figure it out, at least to figure it out directly. But there's a little trick that we saw in one of these videos. They said often when you don't know how to figure out the area, split it in half. All right, so split it up at the mean at 30, because I think you could figure out this side of it, the red side, and then I think you could figure out the blue side, and then maybe you'd recognize that the original shaded region is just the red stuff plus the blue stuff. So how are you going to figure those out? Well, this red stuff, if it went from 18 to 42, from 2 standard deviations below to 2 standard deviations above, you'd know from the empirical rule that it would be 95%. But it doesn't. It only does half of that. It doesn't go from 18 to 42. It just goes from 18 to 30. So what that means is this area is half of 95%. In other words, 47.5%. Similarly, if this went from 12 to 48, it doesn't. But if it did, I would have shaded in 99.7% of the area. I didn't though. I only shaded in half of that in blue. So it's 99.7 divided by 2 that's shown in blue here, 49.85. And so to figure out my final answer, maybe I'll write it down here. All I got to do is add up 47.5 and 49.85. And the answer I end up getting is, let's see, 96.7.35. Yeah, there we go. Just put a box around it because it's my answer. There's some empirical rule stuff. Question 3 and 4, I guess more so question 3, is fairly similar. In fact, 3 is going to be pretty similar to 2. We're looking for the same thing. Using a calculator function, find a more precise estimate to the percentage of his games in which Steph scores between 18 and 48 points. So it's the same thing. You're still trying to find the area between 18 and 48. So maybe I can draw that picture again. I'm sorry, you got to keep drawing these pictures. I know it's a little bit annoying at times. Throw the 30 in the middle and count up and down by 6s. And you could argue that the counting up and down by 6s isn't all that necessary when you're using calculator functions like we are here. But I think it says to do it in the instructions, so I'll do it. And I want 18 to 48. So that's the same shaded region it was before, from here to here. I'm just going to come up with the answer a different way. And what you'll see is by using a different method, I get a slightly more precise answer. So what I'm going to do this time is I'm going to use a calculator. So I'm going to bring my calculator over here. The calculator function that I want to use is the normalCDF function. You hit second and then variables to get into the distribution menu to access the normalCDF function. The normalCDF function, you need to know that it always wants the lower bound, which is 18 in this case, and the upper bound, which is 48 in this case, and then the center and the spread. I know it says mu and sigma, but don't think mu and sigma, think center and spread. Yeah, in this example, it's the exact same, but later it won't be. If you have a user-friendly input version of the calculator, you get to see all this. If you don't, it'll just say normalCDF and open up parentheses, in which case you need to type in the 18, comma, the 48, comma, the 30, comma, and the 6. Comma key's right here, by the way. Hit enter, it'll spit out the answer. It'll tell you how much area is shaded in there. And that is 97.59%. I guess these are all percentages. So note that it's pretty similar to the answer that you got here, but slightly off. Instead of 97.35, it's 97.59. I think I said to explain how you got your answer. So I guess you could say it was normalCDF. Lower bound was 18. Upper bound was 48. Center was 30. Spread was 6. And that gives you this. Finally, the fourth and final question on this quiz concerned a different calculator function. It'll turn out it's the inverse norm calculator function. If you read through this problem, essentially what it's asking for is a number that's so high that the area above that, the area to the right of that point, is only 5%. It takes a little practice being able to read these problems and tell that that's what it's asking you to do. I'm telling you, that's what it's asking you to do. So you draw your normal distribution. You still put 30 in the middle. You don't bother counting up and down by 6s this time, because the question is asking you not for an area, but for one of these numbers down here. And it's hard for you to find this number. It's hard for you to draw the picture until you know what this number is, right? Imagine counting up by 6s. How would you know where to put this x? So we leave those off. What the problem tells us is that the area to the right here is 5%. There's only a 5% chance that he scores more than this many points. And we got to figure out what that number is. Well, to get that, you can use the inverse norm function on your calculator. But there's a problem. The inverse norm function always wants the area to the left of the point you're looking for. This problem doesn't tell you the area to the left. It tells you the area to the right. But you could be kind of clever and be like, well, if 5% is the area to the right, then 95%, in other words, 0.95, is the area to the left. My mean is still 30. My standard deviation is still 6. The inverse norm function on your calculator wants area to the left, the center, and then the spread. And if you type those all into a calculator, I guess first note that it's in the same menu, second then variables to get into the distribution menu. Then go down to inverse norm. And the area it means to the left, the center, and the spread. Hit paste, it'll spit out an answer. That answer is not a percentage. It's a number that shows up down here on my x-axis. It's the number of points that Steph Curry would have to score to satisfy the criteria given in the problem. So 39.87, since I asked you to round to 2 decimal places. So this would be the answer. And I suppose that would end this written problem. So maybe I'll end the video right here.